Hello everyone, welcome back to Think Lab by Saurabh. So today we are going to understand the complete journey from deep learning to GAN and finally the era of generative AI. So by end of this video, you'll understand the how ChatGPT, Gemini, Cloud, Mid-Journey, Stable Diffusion, and AI generation and AI agent are connected. So let's begin. So if you check the AI hierarchy, so first understand the hierarchy, right? So what is the artificial intelligence here? So artificial intelligence is the broadest field, right? So inside AI, machine learning comes, right? Inside machine learning comes deep learning, right? Inside the deep learning comes generative AI, right? So think of it like this, right? So AI is the entire city, machine learning is the one district, deep learning is the one neighbor of the district, right? And generative AI is the newest and the fastest growing building in that the neighbor, right? So what is the deep learning, right? So deep learning is the branch of machine learning that use the neural network with many hidden layers. So what deep is simply means many layers. So this layer is automatically learn useful feature from the data. So instead of manually writing the rules, the model learn pattern directly from the example. So this why deep learning performs so well on the image, speech and text and video data, right? So now we are going to discuss about what is the artificial neural network. So everything start with the artificial neural network we call ANN. So ANN is inspired by the human brain. So each neurons receive the input. Every input has a weight and the neurons perform the weighted sum, right? So then an activation function decided whether the neurons should be pass information to the next layer. And this ANN has a three major part: input layer, hidden layer and output layer. So the hidden layer are where the learning actually performs, right? So now we are going to discuss one of the most important concept in ANN, forward propagation. So during the forward propagation, data move from input layer to output layer. So each layer extract more meaningful information. For example, while recognizing a cat, so first layer detect the age, second layer detect the shape, and third layer detect the eyes and ear. And finally, and the final layer predict the image contain a cat, right? So now we are going to discuss about the loss function. So after prediction, we compare the predicted output with actual answer. So the difference is called loss, right? So lower loss means better predictions. Higher loss means model is making mistake, right? So now we are going to discuss about what is the back propagation. So now comes to the learning process. So back propagations calculate how much each neurons contributed to the error, right? So backpropagation calculate how much each neurons contributed to the error, right? So this gradient and propagated backward through the network, right? So then the weight are updated to reduce the future error. So this process repeat thousand or even the millions of times. So eventually the network become more accurate, right? So now we are going to understand what is the optimizer. So optimizer decide how the weight should be changed. So simplest optimizer is, like gradient descent, right? Stochastic gradient descent. So modern deep learning mostly use this, this gradient descent. So because it converts faster and more stable. So other optimizer include, ADA grade is there, RBS Pro is there, right? So now we are going to discuss about what is the activation function. So activation function introduced the non-linearity, right? So without update, neural network behaves like a simple neural network, simple linear model. So the most popular activation function is ReLU. So other side includes sigmoid is there, tennis is there, softmax is there. Softmax is mainly used for multi-class classification problem, right? So we have discussed till now activation function. So now we are moving to the deep learning architecture. So now let's explore the major architecture. So feed forward neural network, is the simplest architecture. CNN is mainly used for the image processing. RNN is used for the sequential data. LSTM and RGU solve for the long-term dependency problem. And autoencoder compress and reconstruct the data. So if you check the transformer, transformer natural language processing, right? So transformer is basically used for the NLP kind of things. So now we are moving to the CNN. So see what is a CNN? CNN is called convolutional neural network. So instead of looking at the entire image at once, right? CNN scan the small region. It's called the filter, right? So convolutional extract important features and pooling reduce the image size. So finally, fully connected layer perform the classification, right? So CNN power the face recognition, medical image, and autonomous driving and object detection. So now we are moving to the RNN. So RNN stands for the recurrent neural network. So like CNN, RNN remember the previous information, right? So this make it useful for language translation, speech recognition, and the time series forecasting. So now we are moving to the LSTM and RGU. So traditional RNN forget information about the log sequence. So LSTM introduced the memory cell and gates. So this gate decide what to remember and what to forget. So simply GRU simplified version of LSTM with the fewer parameter. So we know these are the all, if you check the important thing in deep learning, the autoencoder is also there. So what is the autoencoder? So autoencoder learn from the efficient data presentation, right? So they consist of an encoder. So a latent space is there and decoder is there. So they are widely used for the anomaly detection, compression, and denoising, right? So now we are moving to the important thing is the transformer. So transformer change AI forever. Instead of processing one word at a time, they process all words simultaneously. So that this is the key innovation for is the self attention. So self attention help model to understand the relationship between the word even if they are far apart, right? So modern LLM like ChatGPT, Claude, Gemini, Llama, all are based on the transformer, right? So now we are moving to the generative model. So until now our model mainly classified the information. Generative model go one step further. They create entire new context. They go for major generative model include autoencoder, variational autoencoder, GAN is there, diffusion model, auto-regression model, large language model. So if you check the GAN is the most important part in deep learning. So GAN stands for generative addressable network. So it consists of two neural network. One is generator, another is a discriminator. So generator create a fake image, discriminator decide whether the image are real or fake. So generator continuously improve until the discriminator cannot easily distinguish between the fake and real. So this competition produced the high realistic image, right? So there are lots of GAN variants. Researchers develop the many GAN variants like vanilla GAN is there, DC GAN is there, conditional GAN is there, cyclic GAN is there, style GAN is there, big GAN is there, W GAN is there, SR GAN is there. So each variant solve a different problem. Some improve the image quality, some translate the image, some generate the high resolution faces, right? So now we are moving to another most important concept in deep learning that is called with diffusion model. So recently diffusion model have become more popular than the GAN for the image generation. They start with the random noise. They gradually remove the noise step by step. This produce the create a highly realistic image. So stable diffusion is the famous example, right? Now we are moving from large language model, right? Moving to the large language model. So large language model are another type of generative AI. They are trained on the massive amount of data text, right? Instead of generating the image, they generate the language. So for example, include GPT, Claude, Gemini, Llama, DeepSeek, and Mistral is there. So modern generative AI, so if you check the modern generative AI, to today's generative AI can generate text, image, audio, music, video, code, 3D object, even the autonomous AI agents. So this why generative AI is the transforming nearly every industry. So there are lots of application of this generative AI like healthcare, finance, education, robotics, cyber security, drug discovery, scientific research, software development, autonomous vehicle content creation, right? So they are the just few example where deep learning and generative AI are making an impact. If you check the learning roadmap, how can we learn those things? So if you are a beginner, to follow the sequence. Learn the Python, study the mathematics, learn machine learning, master the deep learning, understand the CNN, RNN, LSTM transformer, study the GAN and diffusion model, then learn the LLM, build the RAG system, build AI agent, and finally create the production ready AI application. So if we are coming to the conclusion of this video. So deep learning taught machine how to learn. GAN taught machine to how to create a realistic content. Generative AI taught machine how to generate the entirely new ideas, conversation, image, video, music, and code. So this evolution shaping the future of artificial intelligence, right? So if you found this video roadmap helpful, don't forget to like the video, subscribe the Think Lab by Saurabh, and share with your friends, okay, who want to master in AI from this ground up, right? So thank you for watching this video. I will see you in the next video. Thank you. Happy learning.